Okay, so now for part 2, we got to figure out this third point where the horizontal tangent occurs, or the third horizontal tangent. Okay, now here's the thing. We know that there are zeros of the derivative at x equals 2 and x equals 0. So let's just do this. Let's take f prime, and I'm going to factor an x out of that derivative. 12x squared minus 28.5x plus 9. Okay, I know that 2 is a factor of this, as 0 is a factor of it. Okay, I just took care of the 0 factor. What I really probably need to do now is let's look at 12x squared minus 28.5x plus 9, and let's divide this by x minus 2. Okay, that's the factor that would give me 2 as a 0. So what I can end up doing here is quite easily figuring out what's left over. Okay, if I do this long division, I get a 12x here. This is 12x squared minus 24x. Let's go ahead and subtract that, and I get negative 4.5x plus 9. I need to put a negative 4.5 to get rid of the negative 4.5x, and this is going to be plus 9, and wow, look at that, it goes to 0. So here is my third factor. So f prime of x can be written as x times x minus 2 times, now what does this equal? 12x minus 4.5, so that means that 12x minus 4.5 equals 0, and so x is equal to 3/8 if you do the division. That is the third place where we have a horizontal tangent. And f of 3/8 is equal to, well, plug 3/8 into there, and you'll get what f of 3/8 is. Okay, I just did it, and I got 7.191911. So that's where the third zero is of that derivative. Okay, so I've got 3 critical values here, here, and right here at x. I already wrote it. X equals 3/8. There are my 3 critical values. Okay, so I'm going to go ahead and flip the screen, and I'm going to write those values down. Okay, so I have x equals 0, x equals 2, x equals 3/8. And I'm going to write down the first derivative again too. The first derivative equals, let's see, let me go back a screen here so I can check it out again. It is 12x cubed, 28.5, and 9. Okay, so 12x cubed minus 28.5x plus 9. Let's just check that and make sure. Plus 9x, forgot the x. Okay, 9x, and that's a squared. Okay, good. Take a look at the second derivative. Equals 36x squared minus, okay, 28.5 times 2 is 57. So this is 57x plus 9. The second derivative is going to tell us concavity. So f double prime of 0 is equal to 9, which is greater than 0, therefore it's concave up. F double prime of 2 is equal to, let's see, 36 times 4 is 144 minus, looks like 114 plus 9. That's greater than 0. This is concave up. F double prime of 3/8 is equal to, now I'm going to have to figure this one out. So 3/8 squared, okay, times 36 is 5.0625 minus 57 times 3/8 plus 9. 5.0625 minus 57 times 3/8 is 21.375 plus 9. That is less than 0, and therefore this area here is concave down. So check it out. If we have a graph where at 0 and at 2 and at 3/8 and 2, okay, this is concave up, this is concave down, this is concave up. It means the graph has to go something like this. Concave up, concave down, and then concave up. So that means this point has to be a min, this point has to be a max, this point has to be a min. And we did it! Yay!